Question 12. Determine whether the given quadratic function has a maximum or minimum value, then find the maximum or minimum value. If I look at the equation, f of x equals x squared minus 8x minus 1, this is a parabola that faces up. I know that because the leading coefficient is positive. So we have a parabola that looks like this. And that means it does not have a maximum, but it does have a minimum. The minimum is located here at the vertex. And how are we going to find the vertex of a parabola? Well, recall there is a formula. X equals negative b divided by 2a. This will help me find the x coordinate of the vertex. So this is a negative for this negative. And the b is a negative 8. So we have a double negative 8 divided by 2 times a, which is a 1. The a is the number in front of the x. This simplifies into 8 divided by 2, or a positive 4. This is the x coordinate of our vertex. And I'll look for f of 4. F of 4 means plug in a 4 into the original function. And so we have 4 squared, that's 16. Negative 8 times 4, that's negative 32. And then a negative 1. This simplifies to negative 17. So that means our vertex is the point 4, negative 17. But we need to state the minimum. What is the minimum? Well, the minimum is the smallest output of the function. So in this case, our minimum is just negative 17. It's the output. The output is this ordered pair, the y coordinate. Question 13. This is a parabola that faces down. How do we know that? Well, there's a negative in the front. So that's a parabola that faces down, which means the vertex is up here, and we don't have a minimum. We actually have a maximum. This is a max because it faces down, so we have a maximum. How do we find the location of the vertex? We'll use that formula again. X equals negative b divided by 2a. And for our problem, it's a negative for the negative sign up here. The b is a positive 2. And our a is a negative 1. This gives us an x of positive 2. To find the y coordinate, we'll plug this into our original function. F of 2 equals negative 1 times 2 squared plus 2 times 2 minus 4. Simplifying this is a negative 4 because the parentheses does not include the negative, plus 2 times 2, which is 4, minus 4. And if we simplify all of this, we get negative 4, which implies my vertex is the ordered pair 2, negative 4. But that's not what we're looking for. We're looking for the maximum. The max is negative 4. The highest output is negative 4. And that makes sense because we have a parabola that faces down, and it is actually a parabola that's below the x-axis because the highest value is negative 4 for the output. Question 4, again, will determine if this has a maximum or minimum. There is, again, a negative in the front, and that means our graph is facing down, so it has a maximum. There's a maximum located at the vertex. Now, a lot of students might feel tempted to FOIL this out and then use the formula x equals negative b over 2a, but that's too much work. It's already in that vertex form. It's already in x minus h squared plus k form. So all we need to do is read off the vertex. The vertex is the point HK, which is negative 12, comma, negative 33. This is a positive, so again, you could pretend this is a double negative, and whatever is after that negative represents the h. So our h is negative 12, our k is negative 33. So what is our maximum? The maximum is negative 33. Again, the maximum represents the highest output. Example 15, at the start of a college football game, a referee tosses a coin to determine which team will receive the opening kickoff. The height of the coin in meters after t seconds is given by the function h of t equals negative 0.9 t squared plus 0.6 t plus 1.4. What's the maximum height the coin reaches? We have a parabola facing down. How do I know that? Well, there's again that negative in the front. If it was positive, it would be a parabola facing up. But we know if we toss that coin into the air, it's going to take a parabolic shape. And I know it's a parabola because there's a power of 2 here. So the first step is to use the formula t equals negative b over 2a. I'm using t here instead of x because we have variables of t that represent time. We'll plug in our b, which is 0.6, so it's negative 0.6 on top, divided by 2 times negative 0.9, which is a. This simplifies to approximately 0.333. And this is seconds, so it takes about 0.333 seconds to reach the top of this parabola. Now we'll plug that into our equation. F of 0.333 is equal to negative 0.9 times 0.333 squared plus 0.6 times 0.333. And we'll add 1.4 to that. So we can simplify this with a calculator. This simplifies to 0.980, and our final units is in meters. Don't forget the meters. That coin reaches a maximum height of 0.980 meters. Question 16, we'll find the difference quotient for this function. F of x equals x squared minus 7. The first step to finding the difference quotient is to write it out. I want you to write f of x plus h minus f of x divided by h first. Always start with that, and then you can do the work. So the first part is to substitute that x plus h into the original function. So this is x plus h squared minus 7. That's the first part. The second part is to subtract f of x, which is the whole thing, x squared minus 7. Then we can divide this by h. Now I'll do the scratch work for x plus h squared. That's going to be x plus h times x plus h. And if you do that work, you should get x squared plus 2xh plus h squared. So this is my scratch work. I did that on the side, fold it out, and now I can simplify my difference quotient. The x plus h squared is x squared plus 2xh plus h squared. We have a negative 7. And we'll distribute this negative. This is negative x squared, and that becomes a positive 7. We'll see what cancels out. And in this case, we have the x squared cancels out with the negative x squared. Negative 7 cancels out with positive 7. leaving me with 2xh plus h squared over h. One more step, we notice that all of these contain a factor of h. Divide that by h, divide that by h, and h squared. If you divide that by h, that leaves us with 1h left over. It's all three of these or none of them. So make sure you simplify all three or none of them. And this simplifies to our final answer, 2x plus h. Example 17, again we'll find the difference quotient for this function. First step is to write f of x plus h minus f of x divided by h. Now x plus h needs to be substituted into every single place that we see an x. So this is 8 times x plus h squared plus 8 times x plus h. Again, I have to substitute it twice, plus 4. That's the first part. Now the second part is to subtract the entire function, which is this whole thing. 8x squared plus 8x plus 4. Don't forget that big parentheses. And we're going to divide this whole thing by h. We have to FOIL first. We have to deal with that squared term, and I have already done it in the previous problem. But do that on the side so you know what this should be. It's x squared plus 2xh plus h squared. I'm going to also distribute this to save myself a little time. This is 8x plus 8h plus 4. We'll distribute this negative throughout the second side here. That's negative 8x squared, negative 8x, and a negative 4. All of this is divided by h. Don't forget, it's all divided by h. Now I can distribute this 8 throughout the left side. This is 8x squared plus 8 times 2 gives me 16xh plus 8h squared, and then I'll copy the rest. I like to copy the rest because there is typically a pattern. You'll see that a lot of things should cancel out. And you can see that the 8x squared cancels out with the negative 8x squared. Negative 8x cancels out with the positive 8x. The negative 4 cancels out with the positive 4. And we'll see what's left over. Left over is 16xh plus 8h squared plus 8h divided by h. And if you're careful, you can reduce again. The h cancels out with the h, but there's two h's here because there's an h squared, so there should be just one left. And we can finally simplify our answer as 16x plus 8h. Remember, there was an h squared, so there's one left, plus 8. And in the bottom, it's just a 1, so we'll leave it alone. And here you go, 16x plus 8h plus 8 is our solution. Question 18, let's graph the absolute value. Recall the parent graph for the absolute value. We picked points negative 2, negative 1, 0, 1, and 2. And if you take the absolute value of all of these points, you get positive 2, positive 1, 0, 1, and 2. Recall the vertex form for a absolute value graph is x minus h in absolute value plus k. For this problem, the vertex is positive 7, and positive 4. So we'll start by graphing 7, 4, and that's the point, 7, 4. This parent graph tells me the directions. So start from the vertex always, go left 2, up 2. That's our second point. We go right. We go left 1, up 1. 0, 0 represents the vertex. Again, restart at the vertex. Right 1, up 1. And right 2, up 2. So this gives us the general shape of our absolute value graph. We have the graph done, but it also wants to state the domain and range, so we'll write that down. The domain again is left to right. It goes left forever, to the right forever. So the domain is negative infinity to infinity. For the range, it goes down. It looks like a 4, so it's a square bracket 4, and we're going to go up forever. So our range is square bracket 4, comma, infinity. For example 19, notice there's a negative in the front, and that means our graph is upside down. So if you write your parent graph for the absolute value with the same points as earlier, you're going to realize the numbers on the right aren't going to be what they are. They're going to be opposite. We're going to flip this thing upside down. It's opposite. So we'll start with the vertex. What's the vertex? It's the point 4, comma, negative 3. We'll start with that. 4, comma, negative 3 is located here. And so we'll go left 2, but instead of up 2, we're going to go down 2. Always restart at the vertex. Left 1, down 1. Restart at the vertex. Right 1, down 1. Restart at the vertex. Right 2, down 2. So we have an upside down V shape here for our absolute value graph. Let's draw that a little bit better. We have an upside down V. And we'll finish off the problem by stating our domain and range. It seems to go left forever, right forever. So this is our domain, negative infinity, comma, positive infinity. For the range, it goes down forever. That's negative infinity. But it goes up only to that negative 3. So we have a negative 3 in square brackets. Question 20. This is a square root function. So we'll have to look at a different parent graph, the square root function graph. Recall we picked the points 0, 1, 4, and 9. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. We just need to get the general shape. You can pick more points, but at least pick 3 points for this graph. Recall the vertex form for a square root function is the square root of x minus h plus k. The square root function doesn't really have a vertex. It actually has an endpoint, so we'll call it an endpoint. And the endpoint h comma k here is negative 6, positive 4. Let's graph negative 6, positive 4. And we'll go to the right 1, up 1. That's our second point. And to the right 4. 1, 2, 3, 4, up 2. And we'll get the fourth point here. Right 9. So this is right 6, 7, 8, 9, up 3. And we'll sketch our square root function. It looks like a sideways parabola, but just half of it. And that's it for the graph. We need to state the domain and the range. It goes to the left, -6. It goes to the right forever. For the range, it goes down to a +4, and it goes up forever. Question 21, we have a square root function again, but there's a negative, and we all know that means instead of a regular square root like this, it's going to be flipped upside down, so something like this. Let's look at the parent graph for the square root function. We'll pick the points again, the same points as earlier. This is 0, 1, 2, 3. But remember, since this is upside down, we're going to have to go opposite of what we typically do for a square root function. What's our endpoint? The endpoint is hk, and in this case, hk is a -4, -3. Let's plot the endpoint -4, -3 first. And then we'll go to the right one. Instead of up 1, it's down 1. To the right 4, down 2 instead of up 2. And for the last point, we'll go right 9. So this is right 4, 6, 7, 8, 9, and we'll go down 3 units and connect it all. And this is a square root function. And we're not judging your art skills, so just try your best to connect all the points. What's the domain? It goes to the left all the way to -4, square bracket -4, to the right to infinity. What is the range? The range is, it goes down forever, but it goes up only to -3. So this is our range. -infinity, -3. Question 22, graph the given square root function. Notice in this function the negative is on the inside. What happens when the negative is on the inside? Well, if you look at our original parent graph, 0, 1, 4, 9, we would get 0, 1, 2, 3. And instead of the output being opposite, it's actually the input. These will be the opposite. Instead of facing right like a typical square root function, it's actually going to be facing left. That's what the negative does on the inside. So we'll start with our hk, our endpoint, which in this case is +4, +4. Instead of going right 1, up 1, it's left 1, up 1. Left 4, up 2. And left 9, up 3. From the endpoint. Always restart at the endpoint. And we'll try our best to connect all the points in a smooth curve. And this should still have a slight rise. It doesn't flatten out. So there you go. Here's our graph. The domain is -infinity. It goes to the left forever. Goes to the right. It stops at 4. For the range, goes down at a +4. And it goes up forever. So the range is square bracket 4, infinity. And our domain is -infinity, 4.